Hello, how are you? Welcome to our lesson today. Today we shall learn about chlorine and its compound. We shall introduce the chapter and thereafter we shall discuss it into details. I hope you will enjoy. You'll be guided by me, your teacher, Mr. Juma Nyamawi of War Girls High School. Karibu. Now, chlorine is a nonmetal. In which group of the periodic table is chlorine located? Group 7, okay? So chlorine is a nonmetallic element and it has got atomic number 7. It has got atomic number 7. Okay? Yeah, it has got atomic number 7. Therefore, it is in group 7 of the periodic table. And remember, group 7 is written as VII. Okay, so it is in group 7 of the periodic table and it has got electron arrangement of 2.8.7. So its chemical symbol is Cl, capital C, small l, and has got a molecular structure consisting of diatomic molecules. That is, one molecule of chlorine is made up of 2 atoms. Okay, so chlorine molecule is written as Cl2. Okay, that is a chlorine molecule. Hence, we are saying it is composed of diatomic molecules, that is Cl2. Now, chlorine does not occur freely in the crust or in the environment, but instead it occurs in combined form with other elements. This is because it is very reactive. Okay, this is due to its it is highly reactive. I think the word here is it's higher reactivity, not prior. Higher reactivity. Yeah, high reactivity. So you're saying it does not occur freely due to its high reactivity. Okay, it is always found in combined with other elements, and the chief source of chlorine is in sodium chloride. That is the chief source of chlorine, in sodium chloride, which is found in seawater. That is where we found chlorine in high amount. Okay, so we have actually said that chlorine is a non-metal and it's among the group 7 elements. What is the general name of the group 7 elements? Probably have said they are called halogens. So chlorine is among the halogens. Okay, it is found in group 7 of the periodic table and its electron configuration is 2.8.7. We have said it does not occur freely in the atmosphere because it is very reactive. Therefore, it actually readily reacts with other elements, hence occurs in combined form. And the chief source of chlorine is sodium chloride, which is usually found in seawater. For those who might have gone to swim in the seas, you might have tasted the seawater. It is salty due to the presence of the sodium chloride. Therefore, in the seawater there is sodium chloride, which is the chief source of chlorine. Later we shall see how we can extract chlorine from the sodium chloride in the seawater. Good. Now, how do we prepare chlorine gas? How do we prepare chlorine gas? Okay. Preparation of chlorine gas. Now, We have two methods that can be used to prepare chlorine in the lab. And the first one is oxidation of concentrated hydrochloric acid using a suitable oxidizing agent. Okay, that is action of an oxidizing agent on concentrated hydrochloric acid. So in using this method, the commonly used oxidizing agents are the manganese 4 oxide. Okay, we can use it as an oxidizing agent, or potassium permanganate, mostly known as potassium manganate 7, potassium dichromate 6, and lead 4 oxide. So these are the various oxidizing agents that can be used to oxidize chlorine. To oxidize hydrochloric acid, concentrated hydrochloric acid, to produce chlorine gas. Okay. Now, we can use the setup below for us to see how the chlorine can be prepared using these particular reagents. Okay. Good. So, the setup below can be used to prepare chlorine gas. Now, look on that particular diagram. Okay. I hope you are able to see that we have a thistle funnel. This is a thistle funnel here. And inside the thistle funnel, there is concentrated hydrochloric acid. In the round bottomed flask down here, we have an oxidizing agent, which is called what? Manganese 4 oxide. Okay. So when manganese 4 oxide is used, heating is necessary down here. So you must heat. However, if you're using other oxidizing agents like potassium permanganate, lead 4 oxide, or heating is not necessary. Okay. So what happens when concentrated hydrochloric acid comes into contact with manganese 4 oxide? The concentrated hydrochloric acid, HCl, will be oxidized. That is, hydrogen will be removed from the HCl, hence producing chlorine gas. Okay? Hence producing chlorine gas. So it will be oxidized, that is, the hydrogen will be removed and it will combine with oxygen from the oxidizing agent here to form water, while the acid itself will be reduced to or will be oxidized to form chlorine gas. Okay, we shall see that equation later. Now, at this particular juncture, I want us to study this particular setup here. So, we have said that once the hydrochloric acid comes into contact with manganese 4 oxide, chlorine gas is evolved. Okay. So what do you think is the reason of water here in the first reagent bottle? What do you think is the purpose of that water? This water is supposed to be warm. We are supposed to use warm water here. Okay. Then the chlorine gas which is produced in this round bottomed flask is passed through water and then concentrated sulfuric 6 acid and then collected using this method. So the first question is, what is the role of warm water in the setup? Now, the role of warm water here is to remove any traces of hydrogen chloride gas, which might have been produced when concentrated hydrochloric acid is heated down here. If it is heated, sometimes it may vaporize, forming hydrogen chloride gas. Because hydrogen chloride gas is more soluble in warm water, okay, the mixture of the gases, that is chlorine and hydrogen chloride gas, is passed through warm water. This will remove this particular gas. Okay. Then The remaining chlorine is passed through concentrated sulfuric 6 acid. What do you think is the role of concentrated sulfuric 6 acid? Okay, concentrated sulfuric 6 acid here actually is a drying agent. Therefore, it dries the chlorine gas. Hence, we are able to collect dry chlorine gas down here. Okay. So, what is the name of this method that we use to collect the gas? It is downward delivery, because the delivery tube is pointing downwards. What is the other name of the method? It is upward displacement of air. Okay. Now, chlorine is collected using this method because of one property. State the property of chlorine that can be used to collect the gas using this method. This is because the gas is denser than air. Okay? Yeah, the gas is denser than air. Now, we have another diagram here. Now, we are using the oxidizing agent manganese 4 oxide. We have said if you're using manganese 4 oxide, we must heat. Okay? So, the focus here is on this particular gas jar. What is the color of chlorine gas? As you can see in the diagram, the color of chlorine gas is green-yellow in color. Some of you will say it is green in color. But in a nutshell, chlorine gas is green-yellow gas. It is bad to say greenish-yellow. It is recommended that you say it is green-yellow in color. Okay? Good. So this is the setup that we can use to prepare and collect chlorine gas. The question is, how do you confirm that this gas jar is full of the gas? Okay, it is very easy. The gas is colored. Therefore, if the gas jar is full, you can easily see. But apart from that, you can place moist blue litmus paper on top here. Okay? Moist blue litmus paper on top here. So, when the gas jar is full of chlorine gas, the moist blue litmus paper will turn to red. Okay? The moist blue litmus paper will turn to red. But after some time, it is bleached again, meaning that it will turn to white. After some time, it turns to white, meaning that it is bleached. After some time, it is bleached. Is it clear? We shall see diagrammatically later. So this confirms that the gas which is being collected there is chlorine gas. Now, we want to go ahead and learn about the reactions that occur inside this particular conical flasks or round bottomed flask. So I've said that when manganese 4 oxide is used as an oxidizing agent, the reaction which occurs in the flask is as follows. That the manganese 4 oxide will react with concentrated hydrochloric acid, and this forms manganese 4 chloride, manganese 2 chloride, and water and chlorine gas. Okay, so initially it was manganese 4 oxide, and here it has formed manganese 2 chloride. Okay, so you can see here the name have changed. It was manganese 4, now manganese 2. Therefore, the manganese have undergone reduction. Reduction is decrease in oxidation number. Okay, so on the other hand, hydrochloric acid has been oxidized into water and chlorine gas. So when other oxidizing agents are used, the reactions are as follows. So when we are using potassium permanganate, it will form now our chlorine gas, manganese 2 chloride and water. When we are using lead 4 oxide, it will actually form lead 2 chloride and chlorine and water. I think you're able to note on the names of this oxidizing agent. Here it was lead 4 oxide, but the product which is formed of that of the lead is lead 2 oxide. So lead was lead 4. Okay, it changed to lead 2. This means that it has undergone reduction. Reduction is decrease in oxidation number. The oxidation number has changed. Okay. On the other hand, our hydrochloric acid has been oxidized, to chlorine and water. Sawa. Good. So we have said that if we use manganese 4 oxide as an oxidizing agent, remember this is not the correct name. There is typing error here. Manganese 4, we use the Roman 4. Okay. When we use manganese 4 oxide, we must heat. Heating will speed up the reaction. Sawa. Good. Now, what are some of the physical properties of chlorine? Because we have talked about all this, or we can pass through this literature very fast. We've said that in the reactions above, concentrated hydrochloric acid acts as a reducing agent and itself is oxidized to water and chlorine. The gas is passed through warm water. I've said this to remove most soluble hydrogen chloride gas, which has been formed when the acid vaporizes due to heating. Okay. Then I've said the gas is passed through concentrated sulfuric 6 acid to dry it. Then it is collected by downward delivery or upward displacement of air because it is denser than air. Okay. And when the gas jar is full, the blue litmus paper turns to red, then white, that is, it is bleached. That is what we have said. Okay. Then we have said chlorine is not collected over water. Oh, we have not said this, but we can say it. Chlorine is not collected over water. The reason is that it is very soluble in water. Therefore, it cannot be collected over water. Good. Now, method 2 that we use to prepare chlorine in the lab is electrolysis of concentrated sodium chloride solution. This is what we call brine. You remember brine during solvay process? Okay. We said that when you add sodium chloride until no more can dissolve, it forms concentrated sodium chloride solution. That is what we call brine. So if you electrolyze brine, if you carry out the electrolysis of brine, chlorine will collect in the anode. Okay, I think you're able to see that at the anode there is chlorine gas which is green yellow in color that is being collected at the anode. Okay, so what happens at the anode? At the anode, the chloride ions will be attracted and then they will lose 2 electrons, hence forming chlorine atoms. Okay, those 2 chlorine atoms will again combine to form now the chlorine molecules. So we are saying that the second method that we use for preparation of chlorine is electrolysis of concentrated sodium chloride, and chlorine will be collected at the anode due to oxidation of the chloride ions. The chloride ions will lose 2 electrons, forming chlorine atoms, and those atoms will combine to form the chlorine gas. Okay, good. Now we want to move on to I think the physical properties of chlorine. So chlorine is a gas at room temperature, and if I talk about room temperature, I mean temperature that is the temperature that is 25 degrees Celsius, that is room temperature. Okay, so it is a green yellow gas, and it has got a characteristic pungent choking smell. However, you are not allowed or not supposed to smell that gas. Reason? The gas is highly poisonous. Remember, all halogens, all vapors of halogens are poisonous. Therefore, you are not supposed to smell such gases. Okay. Number 2, chlorine gas is denser than air. Chlorine gas is denser than air. In fact, it is believed that it is 2.5 times denser than air. Therefore, it is collected by downward delivery. Okay? Now, chlorine is fairly soluble in water. It is soluble in water, hence forming chlorine water. We discussed this in Form 2, but we shall discuss it again here. It is easily liquefied under pressure. It is easily liquefied under pressure. Okay? Those are the physical properties of chlorine gas. Now, I want us to move ahead and talk about the chemical properties of chlorine. Chemical properties of chlorine. Good. Now, I want us to emphasize on one. The first one is reaction of chlorine with water. Reaction of chlorine with water. So when chlorine is dissolved in water, or when it is bubbled in water, it quickly dissolves in water, and we say that it forms chlorine water. So when bubbled in a boiling tube containing water, a green-yellow solution, which is chlorine water, is formed. Okay? The chlorine water is a mixture of chloric 1 acid, which is our hypochlorous acid, and hydrochloric acid. So it is a mixture of chloric 1 acid and hydrochloric acid, as learnt in Form 2. So chlorine water is acidic, and it turns blue litmus paper red. The litmus paper turns white. That is, it is bleached. Okay? It is bleached. I want us to emphasize on this diagram here. This diagram here. I think you're able to see. So this diagram inside here is chlorine water. So when you place blue litmus paper here on top, I think you're able to see it. Oh, it has disappeared. Okay. Good. So I think you're able to see it here, that when a blue litmus paper is dipped into this solution, which is chlorine water, it changes to red, and then you're able to see what is the color of the remaining bit. Where are you going? You're not supposed to go. Good. So you're able to see that this is the blue litmus paper we're talking about. And when it is dipped into this solution here, which is the chlorine water, the one which is green yellow in color, it changes into red, meaning that, or showing that it is acidic solution. And then quickly it changes to white, or it is bleached. The bleaching action is due to what? What bleaches that particular litmus paper? Okay, so I hope you have answered that particular question. So the bleaching action is due to this particular substance here in chlorine water. What is the name of that substance? That is our chloric 1 acid. So I said that when chlorine is dissolved in water, it forms hydrochloric acid and chloric 1 acid. Okay? So this chloric 1 acid is the one which actually causes bleaching. It causes bleaching of any dye, okay, any colored material. And bleaching here actually is by oxidation, as we shall see later. Okay, good. Now, I want us to discuss this particular concept of bleaching. We've said that chlorine turns moist blue litmus paper red, okay, then bleaches it. The bleaching action is due to the decomposition of unstable chloric 1 acid, producing free oxygen. So the bleaching action is because of that chloric 1 acid. When it decomposes, this one here, okay, when it decomposes, the oxygen present in it will combine with this dye or the colored material. So this particular substance here called chloric 1 acid will form hydrochloric acid, while the dye will form the colorless material. Okay? The dye here will be oxidized by this oxygen. This will form now the colorless material. Hence, we are saying that chlorine bleaches by oxidation. Okay? So, this means that when you add any substance in chlorine water, which is colored, any substance that is colored in chlorine water, it will be bleached. And the bleaching of dyes by chlorine water is by oxidation. This is because of the presence of that oxygen atom in that chloric 1 acid, which will actually combine with the dye, hence forming hydrochloric acid and the colorless material. So bleaching, as we have said, is by oxidation, and this bleaching is long lasting. It does not actually fade because it is by oxidation, unlike when you are using sulfur 4 oxide, okay, where it is by reduction. When you are using sulfur 4 oxide, the bleaching action is by reduction. This one, when that particular bleached material is exposed into the atmosphere, it gains oxygen again, hence reforming the colored matter. We shall see later. Last but not least, chlorine gas does not bleach dry litmus paper, does not bleach dry dye or dry color. Why do you think is the reason? So when the litmus paper is dry, the chloric 1 acid does not form. So the chlorine has to dissolve. The chlorine has to dissolve in water to form chloric 1 acid, which now will bleach the dye. Okay? Good. So far, so good. Now, what happens when you place chlorine water in sunlight? We learned that chlorine water is decolorized when exposed to sunlight. This is due to decomposition of the green-yellow chloric 1 acid to produce nascent oxygen. Okay? So like here, when you expose our chloric 1 acid into air, the light, the energy from the light, that is the UV light, that energy from UV light will decompose chloric 1 acid, which is green-yellow in color, to form hydrochloric acid, which is colorless, and oxygen gas. So the chloric 1 or the chlorine water will change from being green-yellow to colorless. This is due to decomposition of chloric 1 acid to form hydrochloric acid, which is colorless. Okay, let us see that in a diagram. So in this diagram, it is a very common diagram. Yeah, You are able to see that here you have chlorine water, which is green-yellow in color. If you leave it for some time, it will decolorize. It will change into colors, and then there will be a colorless gas which will be collected on top here. The colorless gas is due to the production of oxygen. The chlorine water will change from being green-yellow to colorless. This is due to decomposition of the hypochlorous acid or chloric 1 acid to form HCl. HCl is a colorless liquid or a colorless solution. Therefore, the chlorine water will have been decolorized, and on top here there is formation of oxygen. Okay, the equation is the one which I've seen it earlier here. I think we have to see it again. Okay, so we have said that the chlorine water, green yellow, when exposed to sunlight changes to a colorless solution, which is hydrochloric acid, and a colorless gas is given out. Sawa sawa. Good. Now, in our next session, we shall continue with the chemical properties of chlorine. We shall stop there for now, and we shall resume later to learn about how chlorine reacts with metals and non-metals. Otherwise, have a nice time. See you. Okay, bye bye.